GCF is the very first step in every single factor problem that you always are going to do. You might not always have a GCF, but you're always going to check for one. Remember that a GCF is the greatest common factor. Recall that a factor is a number that divides a value exactly. We can look at natural number factors. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12, because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Factoring is the process of finding the individual factors of a product. However, we can find the factors of polynomials. Remember that if something's prime, it only has two factors, one in itself. The same thing happens with polynomials. If I look at this first example, what's the GCF of 42, 60, and 90? Well, if you can't see that right away, you can use factoring, the process of finding individual factors, in order to see it. I'm going to factor all of these numbers. You can pause now, and then I'm going to do it. Here I've created prime factor trees for 42, 60, and 90. The greatest common factor is the factor that all of them have in common. And let's start with 2. 42 has a factor of 2. So does 60, and so does 90. And so part of the greatest common factor for all three of those is a 2. Now we go on to the next number. 42 also has a 3. 60 has a 3, and 90 actually has 2 3s, but at most, it only has 1 3 in common with the other two numbers. And so a 3 is part of my greatest common factor. Now I look at the 7. None of the other numbers, 60 nor 90, have a 7, so 7 will not be a part of my greatest common factor. I now move over to the factor of the 60. That has a 2, but since 42 doesn't have any more 2's, it's not part of the greatest common factor. We can also see that this has a 5, and while this does have a 5, they don't all have a 5, therefore it's not part of it. Neither is this 3. And so the greatest common factor between 42, 60, and 90 is 6.